All right, all right, all right. So we have added rational expressions. We've subtracted rational expressions. We've multiplied rational expressions. What's left? To divide. Let's go ahead and divide some of these fractions. Let's take a look at some numbers first. A couple ways to do these problems. You can go ahead and divide right across the top, just how we multiplied right across the top. If you did that, 16 divided by 4 is a 4. 1 divided by 3 is a 1/3. Ooh, now we got fractions within fractions. Well, guess what? That's what dividing fractions is. It's fractions within fractions. So another strategy we have, instead of thinking about how many 1/3 fit into 4, which is going to be a bunch of, think about if you had 1/3 and making a recipe, how many 1/3 cups would you need to fill in order to get 4 cups, right? So that's really the question that we're asking here. There's another strategy that we will talk about more in class, but to give you the shortcut here, it's 16 over 1. You keep the first one. Let's change the sign and multiply by the reciprocal instead. Instead of dividing, we're going to multiply by the reciprocal. Now we've got 48 over 4, which is 12. It would take 12 of those 1/3 cups to fill up a full 4 cups. Now, before we just rush ahead, there are some other strategies we can have. Remember what we did last video? Factor, factor, factor. Take that 16, factor it into a 4 times 4. Cool, cancel out a 4 over a 4. And now we can see on top we got 4 times 3 is 12. 12 over 1 is 12. So factoring is still going to be key after we flip our fractions. All right, do you want to factor first? Do you want to flip first? Doesn't matter to me. Let's go ahead and keep our first fraction. Nothing's changed. Oh, you want to change the sign? You want to flip the sign? Then you got to flip your fraction. Cool, now let's go ahead and factor, factor, factor. I see a 4 that I can take out of x and out of 16. I see nothing I can take out of x plus 1. I see a 3 that I could take out of the x and out of the 3. And I see a 4 that I could take out of 4x and the 12. Cool, instead of multiplying, instead of actually dividing these, let's go ahead and factor and then cancel 4 over 4, x plus 1 over x plus 1. Watch, you cannot cancel these 3's. That 3 is part of something else. So what do we have on the top? We got a 3, and we've got an x plus 4. On the bottom, we've got an x minus 3, and we're done. All right, heavy duty already, right? We're going deep into it. Let's just go ahead and write our first fraction. Nothing's changed, right? It's like you're going through life. Nothing's changed, nothing's changed, nothing changed. Oh, dramatic event. Division's changed to multiplication. Guess what? That affects the rest of your life. It affects the rest of this fraction. It flips it. It flips it. Cool, now let's go ahead and factor, factor, factor. If you want, you can use the factor boxes. I think we've done enough of factor boxes, so I could do this one in my head. X plus 1 and x plus 3. That will check me off there. On the bottom, I can do a greatest common factor with a 5 and an x plus 3. That checks me off there. Slow it on the video if you need some help. I'm going to go ahead and factor a 5 out of this top part. And I've factored that. And then x plus 1 squared, I'm just literally going to write it twice. That's what it means. Cool, we factor, then we cancel. Ding, ding, ding. X plus 1 over an x plus 1. X plus 3 over an x plus 3. 5 over a 5. My final answer is a 2x plus 3 over an x plus 1. Put the parentheses if you want, but there is how to do that problem. Change it to multiplication, then factor, 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 just like we did in the last video where we were multiplying rational expressions. That's really all we're doing. We're going to go ahead and take this dividing rational expressions problem and say, it looks all right. That's okay with me. Nope. I'm going to change it to multiplying, and we're just simply going to flip that fraction. Cool. What did we do in the last video? Factor, 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 factor. What does 18x squared mean? 18 times x times x. See anything you can factor out of the bottom? How about a 9? That would be a 3x plus a 1. Here's factoring or multiplication. I could factor a 3 out on the top, and I could factor the 3 and separate all of the x's there and just literally write what that problem means. Let's go ahead and cancel. 18, I don't see an 18, but if I want, I can factor that into a 9 times 2. And now I can go ahead and cancel a 9 over a 9. I don't have a 2 to cancel, but I see an x that I can cancel. I see another x that I can cancel. I see a 3 over a 3 that I can cancel. I cannot cancel these plus 1s. They are part of other factors. So what do we have left for our final answer? I see a 2 on top. I see an x plus 1 on top. I see a 3x plus 1 on the bottom. And I see an x on the bottom. It's kind of standard to write that out front of a group or out front of a parentheses. Let's go ahead and do one more and then wrap things up. X squared minus 25 over a 4x minus 3 cubed. Cool, I'm fine with that. Let's go ahead and change it to multiplication. It's going to make it easier. And we simply just flip that fraction. Cool, now we're going to factor. This top is a difference of squares. That's an x plus 5 times an x minus 5. On the bottom, we've got 4x minus 3, 3 times. Takes me a little bit, but it's just going to help me later on. What can I factor out of the top right? How about a 2? 2 times 4 will still give me 8 with the x. And then 2 times a negative 3 will give me that negative 6. On the bottom, I see a 2 times an x, and then a 2 times a negative 5. And now I'm ready to cancel. So we factor all those factors and cancel out. X plus 5 on top. Yeah, I don't see an x plus 5 on the bottom. X minus 5 and x minus 5, sweet. 2 over 2, sweet. 4x minus 3, 4x minus 3. I got a bunch of options there. And that leaves me on top with an x plus 5. On the bottom with some 4x minus 3s. If you want to shortcut it, you can use an exponent. That's what an exponent is. It's a symbol, a shortcut to tell you how many of those things that you got. And that's what we got. Dividing rational expressions. What are our steps? Change it to multiplying. Promise you it's much easier. Next up, factor. We're not actually going to multiply. We're going to factor, which involves multiplying. And then we will cancel. So change it to multiply, factor, cancel.